Today, we're diving into the tech that's finally closing the gap between an AI's brain and the real world. We're talking about Gemini Robotics and how it's building that bridge from digital thought to physical action.
So, let's start with a question that kind of gets to the heart of the whole problem. For decades, we've watched AIs get unbelievably good at digital stuff, right? They can code, they can write poetry, but then you ask one to do something simple like pick up a coffee cup on a messy desk, and it's a huge struggle. So what gives? Well, the answer is what a lot of people in the field call the digital-physical divide. You see, for the longest time, an AI's incredible reasoning power has been kind of trapped in a digital box, totally separate from the messy, unpredictable physics of the world we live in. The challenge isn't just about making something move, it's about making it think and reason in that physical space.
And this is exactly where Google DeepMind's Gemini Robotics enters the picture. Now, this isn't just one single model. It's a whole ecosystem, a complete architectural bridge designed specifically to cross that divide. So let's break down how it actually works.
You know, the easiest way to wrap your head around this is to think of it like a living thing. It has a brain for planning, a nervous system to send the signals, and a body to actually get things done. First up, you've got the brain. That's Gemini Robotics ER. The ER stands for Embodied Reasoning. This is the big picture thinker. It's the part of the system that understands what you're asking, thinks through all the steps, and breaks down a really complex goal into smaller, totally manageable tasks. And here's a perfect example. Let's say you tell the robot, pack a suitcase for London. The ER model doesn't just see a suitcase and start throwing stuff in. No, it's way smarter. It actually queries the web to check the weather in London, figures out that rain is likely, then identifies the right things to pack like a raincoat, and then it plans out the most logical way to pack them. That is real contextual reasoning. Okay, so the brain has this brilliant plan, but how does that plan actually turn into movement? That's where the nervous system comes in, the Vision Language Action Model, or VLA for short. This thing is the crucial translator. It takes those high-level ideas from the brain and turns them into smooth, real-time motor commands for the robot's body. The real magic here is a concept called action tokenization. The VLA model basically treats physical movements like move arm forward, grip lightly, as if they were words. It then strings these action words together to form a sentence of movement. It's a genius way to generate really complex, fluid motions. And the result of all this? It's a massive leap forward called zero-shot generalization. Because the system can reason and create actions on the fly, it can handle objects and do things it has literally never seen before without any specific retraining. This is what takes robotics from just rigid automation to being a truly adaptable helper. Now, all of this is building towards a much bigger vision, what you could call the Android for robotics. The idea is to have one single powerful intelligence that can control many different types of physical bodies. This is a huge shift, moving away from single-purpose machines toward one general-purpose platform that can do almost anything. It creates what's called a hardware-agnostic ecosystem. So a skill learned on one robot can be instantly transferred to a totally different one. No need to start over. And this isn't just theory. We're seeing it happen right now through huge partnerships with pioneers like Boston Dynamics and their incredible Atlas humanoid, and with Aptotronics' Apollo robot. But look, when you have AIs moving around in the real world, being smart isn't enough. They have to be reliable. That's why safety isn't just some add-on feature here. It is the absolute foundation of the entire system. The way they do it is with a multi-layered safety stack. So at the very top, you have what they call semantic safety. Think of it as a robot constitution. It's where the AI brain itself will just refuse to do anything harmful or nonsensical. And then layered underneath that, you have physical veto layers. These are like hard-coded reflexes that will instantly stop any command that pushes the robot past its physical limits. And before any of this even gets close to the real world, every single model is put through the ringer. It's stress-tested against something called the Asimov benchmark, which throws thousands of tricky, weird edge cases at the AI to make absolutely sure its behavior is predictable and safe. And this quote just nails the whole philosophy. When we're talking about physical AI, safety isn't just a nice-to-have, it has to be the first thing you build. It's the foundation for everything else. Okay, so we've covered the tech. Now let's talk about how you can actually start building with it. The bridge from your great idea to a real-world product is the Google DeepMind Robotics Accelerator. For startups just getting off the ground, this program gives you the fuel you need to really get going.
And that includes up to a whopping $350,000 in Google Cloud credits.
So for the 2026 group, it's a 3-month program, a mix of in-person and remote, based out of London. It's specifically for startups from pre-seed to Series A. You get one-on-one mentorship from the researchers at DeepMind, you get early access to the Gemini robotics tools, and a global stage to show off your work. But you've got to pay attention to that deadline.
That gap between the digital and physical worlds, it is closing, and it's closing fast. If you are someone who's building the future of physical AI, this is your shot. This is your bridge. Applications are open right now, but they close on March 25th, 2026. The time to build is now.